Thank you. That's
Uh-huh.
from Toronto Summit. Yeah.
Yeah, so nice. Okay, now all yours. You okay?
No problem. Let
Thank
me
you.
start my
Let
screen.
me
Yeah, I
stop
started the
share my.
recording. Yeah.
Mhm.
And folks, if you have any questions, just type them here, and at an opportune moment, Yogi will answer them. Okay. But we are watching your questions. So,
All right. Good evening, everyone. Good afternoon if you are in East Coast. I think you're all from same time zone. So good evening. My name is Yogi Barot. I'm a migration worldwide tech leader at AWS. This is my sixth year at AWS. Prior to AWS, I was one of the DBA data engineer, like one of you, and working for a government in Canada. And no plan to change any job. I just wanted to retire over there, but somehow I got into cloud and I got into AWS, and here I am talking to all of you. So that's about me. I have 25 years of experience. So today we'll cover why SQL on AWS is a perfect match. In fact, I will be covering this topic because I myself, when I joined AWS, I had no SQL Server, no AWS. I had SQL Server experience, but no AWS background. But then I had to figure out why it's a perfect match, and then I have to talk to the because my role was like specialist essay covering Canada. I have to talk to all the Canadian customers, right? So that's why I figured out why it's a perfect match, and I will share that story with you as well. What are the deployment options for SQL on AWS? What are the migration strategy? What are the best practices? What are the right sizing and optimization strategy? Some of the backup, high availability, security, and cost optimization. So we have a very short time and we have a lot of things to cover. So I will be going through some slides quickly, but at any point, if you have any questions, feel free to pause me and I will be happy to cover and answer them. So first of all, let's cover why they are perfect match, right? So number one reason is it offers you a flexibility, different deployment options, whether you want to BYOL, like bring your own license, or if you want license included, different 300 plus different instance type, an instance family, an instance that you can choose from. There are lot of flexibility in terms of deployment as well, right? So that's one thing. Second thing is reliability, right? This was the thing what caught my attention when I joined AWS, right? The amount of time the whole AWS region. Okay, don't like this time this happened with war in Dubai. That's a different story. But other than that, what I have seen in last 6 years, that the whole region to go down is like more reliable than any other cloud providers, right? So from in terms of reliability, way reliable our infrastructure and the SQL Server Enterprise capability. When you talk about the performance and cost optimization, right, we have a purpose-built instance type, a memory optimized storage, memory optimized instance that's specifically built for databases like SQL Server. And from cost optimization point of view, we have a different options to help you save cost. And good thing about AWS, we have reduced price more than 100 and something, right, times since we started. So every time the new instance comes up, new hardware comes up, it's faster and it's cheaper, right? That's what also attracted kind of me that, hey, this is good. It's always faster and cheaper. So for example, RDS running on R5 instance and running on R7 instance, like 40% cheaper and faster, right? So that got my attention that this is a good offering because it gives me every time the newer what we have seen in the market, the newer iPhone is always like it's faster, but again it's not always necessarily cheaper, right? So but here it's faster as well as cheaper. At the same time, we have a lot of security options like to keep your data secure in cloud, encryption, compliance, different AWS security services that we offer, and we can use an innovations that we offer, and the new capability. So, Paresh, I think you will be monitoring the queue, right? People are waiting
yes,
into the.
yes,
Okay, okay,
yeah, yeah,
perfect. Yeah.
because that is the way we are actually preferring.
Okay.
So that,
Yeah.
okay, cool. I got it.
Yeah. So continuous
Yeah,
sub.
Latifa is my colleague, so be good to her.
Okay. All right. So there are different deployment options, right? So one option is fully managed site. So the preferred option is like you run SQL Server on Amazon RDS for SQL Server. RDS kind of a managed service, right? So it's running SQL lift and shift is as it is SQL you run on premise with no code change. It runs on RDS SQL Server, but it runs on AWS managed infrastructure, right? So you can focus on just on application database performance tuning, things like that. And with RDS, you get managed backups, you get managed highway, you get managed DR, you get managed monitoring as well. So infrastructure managing, patch management. All these things is covered by AWS. So you can focus instead of focusing as an infrastructure DBA, you can focus your time on application DB, application tuning, and work on some of the modernize and stuff. So that's our offering. Second thing is, if you run on IDS, with IDS, it's because it's a managed offering, you don't have access to RDP, like remote login to the underneath EC2 instance, or you don't have access to install some kind of a third party agent, or if you are running a COTS application like SharePoint or Dynamics or things like that, where you need applications and database component installed together. In that case, you need that flexibility. So if you still need a managed environment, but you want some operating system access, you want an SA rights, you want custom configuration, you want to have third-party monitoring tools like Datadog install on your SQL Server. In that case, you can run with Amazon RDS custom for SQL Server. So it gives you a good of both world. And the last option here is an running SQL Server on EC2. So if you want exactly the same experience as on premises, like running SQL Server on virtual machine, this will be something similar. EC2 instance is a similar like virtual machine where you can RDP, you can install your SQL Server, you come with the pre-installed SQL Server AMI as well. You have a sysadmin, right? And you manage everything yourself. Backup, operating system patching, database patching, monitoring, maintenance, everything high availability, everything you manage yourself. So these are the three different options. Um, any questions before I go further? Okay. So let's look at the each option in detail, right? So first option is IDS for SQL Server. So when do you choose IDS and when do you not choose IDS, right? So in case of IDS, essentially, uh, you choose IDS when you want to focus on applications, not infrastructure. You need an automated backup patching HA. Especially for SQL Server Standard Edition, if you are going for an automated, if you are going for high availability, how many of you know Standard Edition need, how many database you can have in always on AG in Standard Edition? If you know, speak up or raise your hand or type the answer. How many database you can have in SQL Server Standard Edition availability group?
16? I don't know. I'm just.
It's only two database, right? So in standard edition, only two database you can have it. So in that case, if you need to, if you have hundreds of database or more like large number of databases, if you need to create an high availability, you probably need to go for enterprise edition. But when you are running with RDS, you don't need that. With AWS managed high availability, even with like more databases, you can still use standard edition and save cost. So that's another very, very good benefit to run high availability at standard edition without using um, always on availability group on your own, right? So it managed
So
automatically.
I have a question. If that is the case, can one of them be like readable secondary, or that is still
No,
abiding by the
yes,
enterprise license?
yes, yes, you can. Oh, so in terms of read replicas, right? You mean the read
Yes.
replicas? Yeah.
Yes.
For read replicas, you need an enterprise edition license because
Correct.
that's
Correct.
not a feature of standard edition. Yeah. But
Correct.
for
Correct.
multiple databases, you can bypass using AWS managed instance. Yeah.
Okay,
It
cool. Thank you.
supports, recently it supports Developer Edition, Express Edition, Web Edition, Standard, and Enterprise Edition. Developer is just recently added for RDS SQL Server. So it gives you a multi-AZ failover, automatic failover. The way availability zone works in AWS is like, say, it's a two or more data center which are up to 100 kilometer apart, right? So availability zone is like it can be in one city, one AZ, and another can be another city, right? And they when you create your high availability, it is not like on one rack on one server. This year high availability is across two different availability zone. It gives you an automated backup, point in time recovery. It also have built-in business intelligent features, SSAs, SSRS, and SSIS as well. So this is where you use RDS for SQL Server. What is AWS responsibility, as you can see here in the blue, and what is your responsibility is just work on the index maintenance, logins, permissions, security, stats updates, query optimizers, and things like that. Any questions on this slide? Okay.
So if this we talking about is for SQL Server, what about the other database like
So
a relational like Postgres or Oracle, something like that? Is that
Yes, yeah. So
that?
RDS, good question. Amazon RDS for today's topic is covering SQL Server and AWS. I can cover any databases, but maybe any other time session I will come and talk. But to answer your question, yes, Amazon RDS comes in 6 different offering. So the Oracle, it comes in Oracle, it comes in SQL Server. We also have RDS for DB2 now as well. We have RDS for PostgreSQL, we have RDS for MySQL and MariaDB, and we have a managed offering with six copies replicas of your database across multiple availability zone. It's called Amazon Aurora offering as well, right? So
Thank you.
RDS comes in different flavor.
Thank you.
So now all good. So next is RDS custom, right? So with custom, I'm not going too much detail. So if you see here at the bottom, EC2, you have full control. RDS is a fully managed where you don't have full control, like no SA rights, no RDP issue thing. If you want good of best of both, then you go with custom. That's where you can get the RDP right. You can get sysadmin at the same time. You can get the managed patching and managed backup and things like that. Why do we use this? You use this because, as I mentioned, if you have, oh, I need to install a third-party driver on my database server. Oh, I need to install this monitoring software. Or I have legacy applications where I need to have my application and database run together on the same server. In that case, you use RDS custom. And the third option is running SQL on EC2. With SQL on EC2 is essentially AWS infrastructure, but then operating system, SQL, and application layer, all of you manage yourself. It's an complete access you have at OS level and SQL Server level as well. There is no difference of this running on premise on AWS. The difference is it's running on AWS infrastructure. You can anytime scale it up, scale it down. You can anytime shut down. You can have different flexibility, different options. But in terms of management and from the DBA point of view, it's the same difference, but it's running on much faster hardware, and it gives you a lot of flexibility of running on cloud. Now, this one talks about the different which option is right for your workload, right? So if your workload is standard workload, you go for RDS for SQL Server with no OS access and then AWS managed patching, backup, everything. If you have a custom requirement, you go for custom, right? Again, you can have my flexible patching, like AWS will not patch, but you can use some of our automation to patch it for you. And when you have running, if you need maximum flexibility in terms of full control of everything, in that case, you go for SQL on EC2. Any questions over here?
So this almost, if I can compare it with Microsoft at the peril of antagonizing you, is that pretty much the more
So
control.
Yeah, if
You
you
have.
want to compare with Microsoft, so RDS on SQL Server is an like a Azure SQL database or Azure SQL managed instance offering,
Hmm.
and SQL on EC2 is kind of an Azure SQL VM offering.
Yeah, correct.
Yeah.
Good. Thank you.
Now let's talk about the migration journey, right? So we just covered the deployment options. Where do we deploy and how do we deploy and what condition you select to deploy where. Now let's see if we want to migrate, what are the three phases? Generally, we go into three phases. One is an assessment phase. In the first phase, we find out, we do a TCO analysis like total cost of ownership. We call it as an optimizing and licensing assessment as well. You run this on premises or you run this on other cloud, how many servers you have, how many database you have, what license you have, what version it is, what edition it is, how much CPU, memory, IOPS, storage, what kind of setup you have. All these things is captured, and based on that, in the assessment phase, we create an discovery of your environment and analyze your entire portfolio and create an readiness assessments, whether to see whether this workload can run on AWS or not, and how much it's going to cost to run this on AWS. So that's the first phase to get started. Then second phase is the mobilize phase. In the mobilize phase, like you build your landing zone. So where you're gonna, if you're running for the first time on AWS, you need to create your control tower, your organizations, your account setup, and the landing zone, and your VPC and everything, networking setup. Then you select your operating model. How do you want to operate for your cloud infrastructure, and you do the wave planning. So in the mobilize phase, you determine, hey, out of my 50 servers, I'm going to start with this one development server first, and maybe after that the 5 other servers, things like that, the different migration wave planning. And the last phase is migrate and modernize. This is where you actually do the migration, migrate your workload, validate your configure, validate the servers, optimize based on your need, and then do continuous improvement based on your usage. So this is generally a migration journey for any kind of cloud migration, right? Now let's take about the SQL Server migration journey, right? So what are the different options you can migrate SQL Server, and how you can migrate SQL Server to AWS, right? So when I'm talking, I will be also talking about two different options like RDS or EC2, and which option works for either of the deployment method. So the first number one method is backup and restore. And the reason why this is number one, this is number one being used by all our users and all our customers, because it's very easy. Everyone knows it. Minimum downtime. You can go up to like transaction log backup frequency. It's a simple architecture. It's a one-time migration. It's best for that. How it works, so you on-premise SQL Server, you take a native backup to local, or maybe you can directly back up to S3 if you are running SQL 2022 and beyond. It has an option to back up directly to S3. I can share the blog post link later on how to do backup directly to S3. And then from there, you restore onto EC2 or RDS, and good to go. Your SQL Server is validate that and cut over, and you are ready to run your workloads over here. Right, so simple, just like backup restore. Instead of backing up to a file store, you can back up to S3, or you can back up to a native folder and then copy that backup file to S3 as well.
So we had done it slightly differently. We had like a 20 terabyte database,
Mm-hmm.
and they gave us what I forgot. It's called Snowbox or something like that.
Yeah,
Um,
so this one is like for, as if you see here, best for smaller database less than one
correct.
terabyte, right? So we
Yeah.
have a different smaller appliances like Snowball, right?
Snowball. Yeah.
Snowball,
Okay.
yeah. So Snowball, and then we also have a Snow Mobile for like petabyte of data. It's like a truck kind of thing. So
Oh,
in that case, you can upload your backup over there and ship it to AWS, and then essentially is kind of an import export feature of your backup files.
correct. Correct. Okay.
Yeah.
Yeah. Good. Thank you.
Um, so that's the one option. The second option is AWS application migration service, right? So with application migration service is we call it as an MGN. The way it works, it replicates everything from on premises to AWS cloud, right? So say on the source on the left side here, your source server is SQL Server, and you install this MGN agent, replicate an agent. So replication agent, what it will do, it will replicate everything on the server at the block level onto a test instance onto EC2. So essentially, everything which is your Windows OS, SQL Server, your database, your applications, your files, your folders, your backup, whatever sitting on this server is continuously getting replicated through a AWS replication server to a test instance or to a staging area, actually, essentially to a staging area. And when you are ready, you can either create a test instance to test, or you can initiate the cutover as a final cutover as well, right, to the target server. So this way, it's everything on your source is getting replicated. You don't need to use any of the SQL Server technology. And because this replication can be set up for continuous, this gives you a minimum downtime, like less than 15 minutes of downtime for your migration. Most of our customers use this method as a second method for migrations if they have large servers to migrate. So, for example, SAP, right? They had like 80,000 database to migrate to AWS. They use this method. They use this method, application migration service. They migrated the SQL Server as it is to AWS. So the way it works is good for minimum downtime. It's easy to roll back because you are not touching your source server at all, and you can have multiple test cycle, test it out, and then again cut over multiple times. You can test from the snapshots, and your servers are automatically converted from on-premise to AWS using this method. Any question? All right. And the third method is if you are using SQL 2016 and up, we have a distributed always on availability group, right? So with distributed availability group, you have a primary and secondary replica using always on availability group on premises. You extend that replica onto AWS cloud. So you create your secondary replica on AWS, and then you use an asynchronous replication. So that way your data from on premise is always in sync with AWS. And whenever you're ready, you can just simply initiate the cutover. In this case, there's a minimum cutover time and then minimum application changes. The reason why, whatever you have on premise has already been configured on AWS, data is continuously replicated, and in minutes you can cut over to AWS, right? So it has a good rollback capability because you can always go back to the primary replica, and you can also do a phased migration approach in this case. A lot of customers use this as a disaster recovery. So even if they are running their primary on Microsoft Azure, they put an AWS as an DR, or from on-premise to AWS as an DR. So they use as an DR option as well. And what is required, you just need a network connect between your on-premises and AWS VPC. Either you need a direct connect or VPN connectivity. So that's also available options for migration. Another option is extend always on AGs, right? So existing always on AG will be extended into secondary multiple nodes onto AWS as well, right? So extend your network connectivity, add the EC2 to the domain. So what's the difference between this and this, right? So this one is just distributed AG, you adding a replica, and this one added a replica to the AG, but then again you have a set of primary and say like you have that setup, async setup on AWS as well, right? And the last option is an AWS database migration service. We call it as a DMS. With DMS, the way it works, we have a replication instance. You have a source endpoint, you have a target endpoint. You define your source as a SQL server. You define your target as a SQL server, can be RDS or EC2, and you can migrate using DMS. This options is the last option. The reason why it 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 is useful as, but the reason why, it's because it's a new service that not many people will be comfortable, so they don't go for this option. But this option is also very very useful when you are doing few things. So you have like 20 terabyte of database and you just want to replicate only 1 terabyte onto AWS, only selective migration. In that case, you can use DMS. If you want to use subset of your schema, you use DMS. If you want to do schema conversion like heterogeneous migration from SQL Server to Aurora Postgres, you have to use DMS. Right. So, and if you want a continuous replication with minimum downtime, you can also use DMS as well. So with DMS, we support homogeneous as well as heterogeneous. So these were the different migration options. Any question on migration before I move to the next topic?
This almost sounds like a SSIS package on steroids.
Yes, yeah. But then SSIS package would need their own servers. This is an managed service. So DMS is an AWS managed service. So you don't need to worry about managing that. You just create an DMS instance, define your source, define your target, and then start the replication. So you can do full load, you can do CDC, everything using DMS. And DMS do much more. So SSIS package you can do like run the custom code and things like that. No, this is just for the migration, only for database migration use case. So it does a lot of like schema conversion, data validations, and things like that as well. Um, Now let's talk about modernization, right? So why you even want to modernize? Because SQL Server licensing cost is increasing day by day, right? With SQL 2022, they increase like another 20% with 2025. So today I was talking to one of the customers, one of the ISV provider in Canada, and they said, "Hey, we just want to talk about the Microsoft licensing cost is so much. Like, can we talk about modernization options, right? What is there for what offering you have to help us move away from SQL Server and still get the same performance and same functionality, right? So that's where we talk about modernizations because the if you want to get the commercial grade performance at 1/10 of cost, because as you know, there's PostgreSQL and MySQL, those are open source. They don't we don't have to pay for any licensing cost for that, right? So it's essentially you get an 1/10 cost, and at the same time we get the AWS native features, as I mentioned with Aurora PostgreSQL. It has six replicas across three different availability zone. It gives you an serverless, high availability, HADR, all these native features and the high performing database, more scalability and more resiliency, right? So the way it works for SQL Server, the best one will be running on PostgreSQL. Why PostgreSQL? I can tell you my story when I when I started before AWS, before my government job. Yeah, I was working in a company where they hired me as a data architect, and they said, "Hey, do you know about PostgreSQL?" And the first time in the interview, I even heard about PostgreSQL and I had no idea. Until then, I was only working on Oracle DB to MySQL, and maybe I worked some on of the mainframe as well. And Sybase also a little bit, but nothing Hadoop as well, but nothing on PostgreSQL. I did not even heard anything about PostgreSQL. So they said no worries. And then next day they throw me with the 3 petabyte of PostgreSQL database in front of it to help troubleshoot the DBS, right? And when I see it, oh, this is so easy. This is like SQL Server. Oh, this is much easier. Okay, this is how it works. And I that's how I learned Postgres on the right on the on the fire on the job, right? So the way it's so similar to T-SQL and P-SQL, SQL and Postgres. They have some differences, but again, it's much similar and easier to convert. That's why we can say refactor to open source like Postgres or MySQL or Amazon Redshift for DynamoDB. How do you do that? How do you get started? Again, same thing. You do your analysis, do your assessment, run the schema conversion tool. Schema conversion tool is a free tool available for anyone. You can go download it and point your database DDL against that. Point the um, database extracted DDLs a file, a SQL file, and run an assessment right now. Take you and like probably 5 to 10 minutes to give you an assessment to see where do you stand, whether you can run this on Aurora Postgres or not, right? So that's analysis piece. After you do the analysis, actually schema conversion not only run an assessment, it also does an conversion. So it does an automatic conversion wherever possible for your schema. So once you convert your schema, you deploy that onto the Aurora Postgres, and then you use DMS for database migration. Uh, Now we have a different tools for modernization. So schemas conversion tool was an desktop's traditional tool. Now we have an Gen AI based schema conversion embedded in DMS as well. So DMS not only does a database migration, it also does a schema conversion. And you can also use DMS for data replication, and on top of it, we do have an AWS transform. So AWS transform does an automated uh, agentic AI based migration using an LLMs and modernize your SQL Server to Aurora PostgreSQL. Right. So we have multiple options to refactor your SQL Server to an open source database. Any questions on that?
So I have a question. So
Mm-hmm.
would this also take care of the programming part of SQL, like the functions, triggers?
Yes, yeah.
Okay,
So
okay.
it would convert your store procedure into functions into Postgres. It will update the triggers, update the function as well. So whatever it could update, it will update to a PostgreSQL compatible. Yeah, but certain things, if you are using, for example, if you are using XP command shell to run on Windows, that's a Windows PowerShell tool that you are using from store procedure. It's going to identify and it's going to flag saying that because of this line of code I cannot convert, but at least it will identify exactly which line number and identify what function or what SQL Server functionality that it cannot convert into Postgres, because definitely this is an Windows OS specific command, and then Postgres is going to run on Linux OS, so it's not going to work. So things like that, which is completely absolutely not convertible, is going to identify and flag for you. So I think we can skip this one. This one talks about the migration strategy. These slides should come before. So yeah, so where if you it talks about look at your requirements. Say for example, if you're 2016, if you need an do you need an HA or not? What size of database you have? Whether you can tolerate the downtime or not? Are you familiar with your always on AG or not? Like how much budget you have? And what's your timeline, like you have aggressive timeline or you want to do phase migrations or things like that. Based on that, you can determine whether you want to refactor or you want to lift and shift RDS, EC2 or Aurora, right? So for example, if you want simple and small database migration, go with backup and restore. If you want automated and fast, you go with application migration service. If you have existing always on, then extend the AG. If you are creating the new always on, then use distributed AG. If you are using heterogeneous migration, then use DMS. And if you want to eliminate licensing, then you go for DMS and Aurora. I'm just going to pause here because there's so many information over here. Just want to make sure any question on this slide.
So if, say for example, I made a mistake in selecting the type of AWS I'm going for, is it is it something that we can do easily to switch back and forth?
Yes, yeah.
So hang in
So,
there. So there is a second part of the same
mm-hmm,
question.
mm-hmm.
Is that, is there any cost involved in that too? So
Okay.
yes, I can
So,
understand you are scaling up, but can we
mm-hmm.
scale out? Is a
Yes,
question.
yeah, you can
Okay.
scale out, scale down as well. So depends on where you are going. So you can move from RDS to EC2. That's what you are asking, or you're asking
Yes,
the
yes,
different
correct.
instance of EC2.
Yeah, yeah. No, no. Say for
Yeah,
basically,
you
either
can
we can
you can
do.
you can go back and forth. That's not a
Okay,
problem. So you can
okay,
just because backup and restore is supported on all the options, so you can do backup and restore to move from one deployment option to another deployment option. Yes.
okay, perfect. Thank you.
Now you might ask me that how do you determine what instance to support and what instance to put for SQL workload, because we have so many of them. So I would say choose based on your workload type, right? So M family is a general purpose for OLTP workload. So we had M5 series when I joined AWS, but then M6i, M7i, now even also M8 series is also there, right? So all of those are examples of general purpose workload, that it's a balanced for OLTP workload. Now for SQL Server, like memory optimized database, right? So for that you use R family. With R family, use R5, R6i, R7i. Those are the examples. And for extreme memory requirement, so I can give you an example. So for R5 family, you have one CPU and you have 4 gig of memory. So one CPU, 1 raised to 4. But SQL is memory hungry, right? So if you're for 1 terabyte of database, if you give 1 terabyte of memory, it will take it up. So in this case, we came up with this an extreme memory mission critical database family for very large database, right? So this X instance family, X2IEDN, will give you one CPU to 32 gig, 1 raised to 32. So one CPU, 32 gig of memory. So if you have 4 CPU, you will get 128 gig of memory in this instance. And if you just want bustable performance for development, test, or low traffic environment, then you go T3 family. So it's very, very important to choose the right instance. Otherwise, you said, hey, my SQL is, or your AWS is very slow, right? But it's because you have not selected right instance, right? So many times I had to go on the customer call and then just help them give the right instance based on their workload, right? So it goes based on your CPU, memory utilizations, peak versus average workload requirement, your growth projection, how much of projections you have in next 1 to 2 years, and then what are the cost optimization opportunity you have it. So you start by current sizing based on the OLA, and then you monitor it for 2 to 4 weeks, and then you optimize based on your usage pattern. Again, this instance size you can change anytime, right? And when you're changing this, you just need to shut down and start, and then your instance will be changed to another instance. You downsize, you upsize, anything can be done instantaneously. That's about the sizing. Now let's talk about the storage, right? So in terms of storage, we have multiple options. So GP2 and GP3. GP3 is our general purpose storage. It goes up to 16,000 IOPS, and it has 1 gigabyte of throughputs, and that's the most cost efficient storage. If you want SQL Server high performance database, I would say go for IO2 storage. It goes up to 64,000 IOPS, and it gives you mission critical SQL Server workload. Um, Again, look at your IOPS and throughputs on premises. How do you find out your IOPS? Just simple thing. We all are DBA. We know, just open your Windows Explorer performance monitor, and then run disk read per second, disk write per second, sum it up to get your IOPS, and then same thing, disk read bytes per second, disk writes byte per second, sum it up, that will be your throughput, right? So select the storage based on your need. And for SQL Server, do I need multiple volumes? I have seen this so many times. Customer has like 10 different drives on premises, and they just mimic everything to AWS same, right? I would not do that. I would just say one for operating system, TimeDB put on instant store. I will talk about instant store if we have a time. Just looking at the time, I'm just gonna speed up. For your data, you put your MDF on one drive and then log another file and then backup. You don't need more than this. This is your optimal performance structure. For TimeDB, one tip, that put your TimeDB on a different drive, which is an NVMe drive. So in AWS, some instance has an instant store. We call it as an NVMe store. That's where you get 100,000 IOPS, and that doesn't count towards instance performance. That's very, very fast. And you put your TimeDB over there for optimization, and the TimeDB should have maximum number of file equivalent to the CPU, vCPU on the server. So for 8 vCPU, put your MDB to the 8 files. Any questions before I move to the backup strategy?
This is pretty solid.
Okay, thank you. So let's talk about the backup strategy. So with RDS, we don't need to worry because automatically daily snapshot, you can take transaction log backups every 5 minutes. Not you can take, it is already taking transaction log backup every 5 minutes. Point in time recovery up to 35 days, it keeps your data. There is no performance impact on any of the things, and it's stored in S3, which is 11.9 durability for backups. For EC2, again, you can do native backup to S3, or you can use AWS backups or EBS snapshot. So what is this difference between EBS snapshot and AWS backup? So AWS backup essentially take a snapshot of your EBS volumes. Remember, this is called EBS in AWS terminology. The C, D, E, F, G, all these drives are different EBS drives, IO2 or GP3. This is the storage type. Okay, so these are the EBS. Now going back here, when you run an EBS, you can take a snapshot. What is a snapshot? Snapshot is just like a backup as of what is my everything on this drive as of it's putting that onto the backup, and that is going as an incremental backup, and it's VSS consistent. That means it's consistent with SQL Server snapshot. With AWS backups, it still uses snapshot technology, but it's a centralized manage that you can manage all other resources together with EC2 instance into same backup policy, and you can have that different backup policy retention and then things like that, and you can store the backup to another region as well, like cross region copy for DR as well. So
So
that's
these
about backup.
backups, I
Hmm.
have a question about the backups, right? So these backups that you're talking about, snapshot, they are the snapshot of the disk subsystem at the time. So
That's correct.
does it quiesce the SQL Server for that split
No,
second?
it
No?
doesn't do that. No, it's a
Okay, okay,
VSS. It's a VSS consistent. So we use
okay,
that
cool.
technology. Yeah.
Okay, thank you.
So backup best practices, test your restore regularly, implement the backup retention, use cross-region replication for DR, or definitely monitor your backup using CloudWatch, and document your RPO and RTO, because sometimes when I talk to customers, I need this to be available in multiple region. And when I said, what's your RPO RTO? They said they don't have RPO RTO. So on premise, they are running on one server with no high availability. On AWS, they want to run on multiple region with like almost like synchronous replications. I said that's not going to be happening, right? So you just need to first understand how does the RPO RTO works, how does the cloud infrastructure work, what kind of RPO RTO you can achieve with what different options. So that's another full 1 hour session for DR, maybe another time. So let's look at that RPO, RTO, and high availability options, right? So let's just focus on this RDS first on the left side, right? With RDS multi-AZ, you can have automatic failover up to one within 30 to 60 seconds. It will automatically fail over to your secondary. And the data is replicated synchronously across multiple nodes with no data loss. And your application is transparent because it's the same endpoint of the one endpoint that use in applications. Even if your SQL Server failovers from primary to secondary or secondary to primary, your application has no impact. So it's a transparent to applications, and it's zero downtime maintenance patching. So that's for IDS. You get really high availability with AWS managed service, which you don't have to worry about anything in terms of high availability for this thing. Now, uh, as I mentioned, first you need to understand. Now let's look down here. What are the different options? We'll look later on, but what are the design consideration we do, and then we decide options. So first you define your RPO and RTO. RTO is a recovery time. How long it will take for you to recover in case it failed, like 5 minutes, 10 minutes, or I have 2 hours. And RPO, I can recover in 2 hours, but I don't want to lose any data point. So my RPO is only 1 minute or 5 minutes. Maybe 5 minutes data loss is okay, but then I have 2 hours to recover. So those are your RPO, RTO. Then you determine balance cost versus availability and plan your application accordingly, put that endpoint. And then you plan your HA and DR option, right? So with always ons, you can get seconds of RPO with RTO minutes. With fail FCI, SQL Server failover cluster, we didn't talk about this option on AWS. We do have a shared storage called Amazon FSX, FSX for Windows file share. that gives you and shared storage between two availability zone multi-AZ. So that way you don't need to worry about setting up HA. Your storage is automatically replicated from one secondary to primary, and that gives you zero RPO, zero data loss, and then RTO in minutes. Multi-AZ manuals, it takes minutes and hours, and read replica takes minutes as well. So these are different HA option. Any questions? I'm just looking at the time and
Yeah,
any question?
it's about
Mhm.
6 minutes to go. So
Sure,
if you
no,
want to hang around, that's fine. But at 8 o'clock, we have to let them know that we
sure,
are at one. Okay.
no problem. Let's talk about the security. So security point of view, that's again another big topic that we can do security for migrations. AWS by default gives you encryption at rest. So we use an AWS KMS, key management service, for RDS and EBS. EBS volumes are encrypted, by default encrypted. In transit data is encrypted using SSL or TLS for connection TLS3. And TDE support in terms of SQL Server, TDE is supported for enterprise editions, and your backups are also automatically encrypted. So that's for encryption. Access management, you have Windows authentication, SQL authentication. You can have good news with RDS. You can have your Active Directory, whether it's in Azure, it's in on-premises or in AWS, on a managed AD. You can directly use an AD authentication, and you can also use SQL authentication. You can also have IAM authentication. You can have secret manager to store your credentials and auto rotate as well. And for any of the API calls, you can use CloudTrail for logging. So that's about access management. We get the network security at the VPC level, firewall and things like that. And everything you can monitor like PCI. This is the database is all, everything which I talked is PCI DSS, HIPAA, SOC, ISO certified. And you have some AWS services to monitor this. I'm going to skip this monitoring slides, CloudWatch, performance insights, and optimization tools. I'm going to talk about the cost optimization strategy, right? So what are the licensing options when you bring this SQL Server to AWS? So if you have made heavy investment, if you have a software assurance, I would say bring your license to AWS. With RDS custom, you can bring your license. With EC2, you can bring your license, and that way you have more savings because you already invested that money into licensing, you bringing it to AWS. You also have a license included instance if you are just starting new, or you don't have software assurance, or you're running SQL 2016, which is already going to be end of support in 3 months. So in that case, you can probably use license included on AWS. With that, you have multiple options. You can have reserved instance to get up to 72% savings. You can have savings plans. You can have right size and save money. You can go GP3 and save additional 20% cost. You can stop and start non-production workload and then save cost, right? And you can migrate to Aurora, save 90% of licensing cost, right? So these are all different way you can optimize your SQL Server and save cost. We also have some other offering another program if you have large SQL Server workload with like 300, like I don't have exact number, but like if you have large SQL Server workload with more servers, you can reach out. We can give you some programs like map that covers your first year 25% of your first year ARR and things like that. We have some other programs that covers your licensing off as well. So we have a lot of programs and offering to help you optimize and offset your licensing cost for running SQL Server on AWS. um, Now, let's see typical customer journey. When you're starting new on AWS, you first go through discovery and assessment phase. I just talked earlier in the beginning. Then you do the pilot migration. You migrate your pilot database. Here we help with something called EBA. EBA is like experience-based accelerator. This is where we come. AWS comes with your account team. We get your executive buy-in. We pick your sample applications with sample database and migrate to AWS, and we that's a three in 3 days we achieve everything like setup migration and get you started onto AWS. And then we do help you with the wave planning and then do the production migrations, and at the end, once you migrate, you do optimizations and modernize and after. um, so these are the 6 different steps. Yeah, So, in summary, as what the title says, SQL Server and AWS and Happy couple a perfect match in terms of flexibility, reliability, performance, security, cost optimize, and innovations, migration supports, and best practices. We have hundreds of partners that can help you support and offset your migration cost. We have ProServe that can help you as well. We have experts like myself that can help talk to the customers and help migrate to AWS and then help them with any of the issues they have, share the best practices and things like that. I think with that, I'm just going to write at time and I'm just going to pause here and then see any questions that you have.
We don't see any questions, but if anybody likes to have any social chit chat or anything like that, this is a good time. If any of you are looking for a job, let me stop the recording. Then you can ask if you're looking for a job because I don't want your boss to see this on YouTube, right? So give me 1 sec. I'm going to stop the recording, right?
Oh, you're going to post this on YouTube?
Yeah, if
Okay.
that's okay for you. And if